Welcome to the Quantanix YouTube channel. This is NextLayer, our podcast series, and you're listening to episode 2. Today, we're plunging into a really fundamental story, how technology rewrote human evolution. We're talking about technology, reshaping human evolution. It's not just about genes, is it? We're looking at tech as a core driver.
Absolutely. Shaping who we are biologically, socially, even how we kind of see ourselves.
Yeah.
We often picture evolution as this, slow biological process only. But the sources we've looked at, they show this constant, powerful interaction. Technology's been right there with our genes.
Shaping the journey.
From the very start, those first tools,
Yeah.
right up to today's stuff. It's deeply embedded in us.
Okay, so let's dive deeper then. We've got this fascinating report tracing that whole intertwined history.
Yeah, technology and human development.
From chipstones to, everything now. And our goal here is to pull out the key insights, right?
Exactly. Understand the critical ways tech has steered our path.
We want to make it clear for you, the listener. Find those aha moments, but, keep it engaging, not too dense.
And what's really fascinating right from the beginning is that basic tool use. It's not uniquely human. Other animals use tools.
Right. Chimps, monkeys.
But the report stresses the habitual nature of our tool use and the sophistication. That's where we really diverge.
Okay, so we're talking way back, over 2.5 million years, Homo habilis.
Those first shaped stones, they weren't just like random finds. They were deliberate solutions.
For food, hunting, changing their world.
Exactly. And there's some amazing recent experimental research on this, brainwave studies.
Oh, yeah.
Yeah, they had people replicate making those ancient tools, just chip stones, and they saw unique neural activity, patterns you don't see when, say, a chimp uses a stick.
Wow. So even that basic tech was linked to how our brains were evolving.
It strongly suggests that. The cognitive demands were different.
So figuring out how to make and use even simple tools, the problem solving, thinking ahead, the motor control, that wasn't just a result of bigger brains. It was maybe helping drive that brain evolution.
Precisely. Like the tool use itself was sort of sculpting our cognitive skills. A feedback loop, really.
Okay. And then comes fire. That's another massive leap, isn't it? About 1 million years ago.
A huge one. Yeah,
Okay.
Controlling fire. Think beyond just warmth or scaring off predators. Think about cooking.
Cooking. It seems so basic now, but the report really leans into Richard Wrangham's argument about how it reshaped us biologically.
Fundamentally,
Yeah.
smaller guts, smaller teeth. Because cooked food is just so much easier to digest. Less energy needed there.
Right, and that saved energy. It had to go somewhere.
Exactly. The argument is that it became available for other energy-hungry things, like building and running a bigger brain.
So fire wasn't just a convenience. It was potentially the metabolic fuel for our big cognitive jump.
It's a very compelling argument. It connects the dots.
Which links nicely to that dramatic increase in brain size over the millennia. From, 400 cc to over 1200 cc?
Yeah, a huge increase. And it wasn't just size, but organization, too. But this brain growth wasn't happening in a vacuum. It was tangled up with the rise of culture.
Ah, culture. So shared knowledge, beliefs, practices.
Exactly. As brains got more capable, we could develop better tools, sure. But culture and social learning, that was the transmission mechanism.
Passing innovations down through generations, building on what came before.
So it wasn't just about one smart individual. It was this collective buildup, knowledge accumulating, leading to technologies way beyond what one person could invent alone.
Which brings us to gene culture coevolution. This is a key concept.
A really powerful one. Our genes and our culture aren't separate tracks. They're constantly influencing each other.
So unlike most species, adapting mainly through genetic tweaks.
We have this whole other layer, this really fast, dynamic cultural adaptation.
And the classic example is lactose tolerance.
That's the go-to, yeah. The cultural practice dairy farming creates this environment where being able to digest milk as an adult is a huge advantage.
So the genes for that spread like wildfire in those populations. Culture literally changed our DNA frequencies.
Exactly. And you can sort of see a similar logic, maybe less direct, with fire and cooking. By making digestion easier, maybe it relaxed the selection pressure for big jaws and guts.
While favoring cognitive skills needed to manage fire, improve cooking, innovate further.
Potentially, yes.
Yes.
It shifts the selective landscape.
And this idea of cumulative cultural evolution, that's crucial too. We stand on the shoulders of giants, technologically speaking.
Totally. Think about clothes or a bow and arrow. Not one invention. It's countless little improvements passed down and added to over time.
And the speed That's the amazing part. Cultural evolution lets us adapt incredibly fast.
Right. Think about humans moving into the Arctic or deserts or rainforests. We didn't wait for genetic changes.
We developed the right cultural toolkit, the clothing, the shelters, the hunting techniques.
Which just highlights the difference with genetic evolution, that slow, multi-generational process. Culture can change within a lifetime.
But that rapid change puts pressure back on us, doesn't it? We need to learn, imitate, innovate constantly.
Absolutely. And this whole interplay, technology and biology, it's literally shaped our bodies. Look at the human hand.
The opposable thumb, yeah.
And the whole structure of the hand and wrist. It's evolved for dexterity, for precise manipulation, shaped by millions of years of tool making.
From bashing rocks to, I don't know, weaving or writing later on.
Exactly. And think about our faces, our jaws. Tools processing food meant less need for massive teeth and powerful chewing muscle.
Leading to flatter faces, smaller teeth compared to earlier hominins.
And back to cooking the extra calories from cooked food. That likely provided the essential energy needed to fuel those growing brains.
It's all connected: anatomy, physiology, technology.
And it's a two-way street, isn't it? Bigger brains allow for more complex tech.
And making and using that tech pushes cognitive evolution further. Things like working memory, attention, abstract thought.
Seems likely. Modern brain scans even show specific areas lighting up during tool use areas linked to planning, problem-solving, motor control.
It's just amazing to think this feedback loop allowed humans to spread across the entire planet, every kind of environment.
Yeah, wider range than any other terrestrial vertebrate. That's quite something.
And again, it's not just our genes adapting perfectly everywhere.
No, it's the synergy. Biology, culture, and the specific technologies we invented for each place. That's the human advantage.
And then technology starts reshaping not just individuals, but whole societies.
Agriculture?
A total game changer. Metallurgy, writing, these allowed for settled life, surplus food, cities, states.
Complex societies.
Exactly. Surplus food leads to specialized jobs, social hierarchies, the whole structure changes.
And societal complexity mirrors technological complexity. You need new tech just to manage it all.
Like writing, math, systems of money or trade, tools for organization. And what about language itself? The report calls it a uniquely human technology.
Which makes perfect sense. It co-evolved with our tool use. How else do you teach someone to make a complex tool?
Or coordinate a group hunt, or pass down knowledge accurately.
Right. More complex tools likely required more complex language, more symbolic thought. And this also relates to cognitive offloading, using tools to extend our minds.
Like writing is an external memory system.
Exactly. We offload the cognitive burden onto the technology. It lets us tackle much bigger problems than our unaided brains could handle.
So we're not just changing the world, we're literally augmenting our own thinking power with tech.
And that creates this constant feedback. Technology changes our environment, which then puts new evolutionary pressures on us. Think agriculture again.
Right. Changes diet, health patterns, social life. Which then selects for different traits, like disease resistance or metabolic changes.
Precisely. Lactose tolerance is one, but there are others related to diet, disease exposure in denser populations.
And tech can also relax selection pressures, right? Like clothing means we don't need as much biological adaptation to cold.
Or medical tech changes how diseases impact survival and reproduction. It really alters the selective landscape.
Which leads to this idea of niche construction. We're not just adapting to environments, we're actively building our evolutionary niche through technology.
We're major niche constructors. Domestication, cities, even altering the global climate. We reshape the environment that then shapes us.
And the report stresses the scale of this now. The cumulative impact is unprecedented, and the speed of tech change is accelerating.
Dramatically. Cultural and tech changes happen in years or decades now, not millennia, like major genetic shifts.
Which raises a huge question. Can we keep up? What are the limits of our adaptability to this constant, rapid change?
It suggests things like lifelong learning, mental flexibility, cooperation become even more critical traits for navigating the future.
And that brings us right up to today, with things like biotech, CRISPR, genetic engineering.
Now we're talking about potentially directing our own biological evolution in a much more conscious way.
Which opens up a whole universe of ethical, social, and evolutionary questions. What does it mean if we can eliminate diseases or enhance traits?
What happens to natural selection? What about equality, diversity?
Yeah.
What does it even mean to be human then? Huge questions.
And then there's AI, artificial intelligence, another transformative force.
Already reshaping work, education, social life. augmenting our decisions, automating tasks.
And the potential for coevolution there. Humans and AI, brain-computer interfaces.
It could blur the lines between biological and artificial cognition in ways that are hard to even grasp right now.
But we also have to face the downsides, the unintended consequences of all this progress.
Definitely. Climate change, biodiversity loss, resource depletion. These are massive challenges stemming from our technological success.
So tech offers huge opportunities, but also serious risks. Our choices now seem incredibly important.
They really are. They'll shape the future trajectory.
So wrapping this up, it's really clear that technology isn't just something we use. It's been a fundamental author of human evolution.
Shaping our bodies, our minds, our societies, our identity.
And what makes us unique is that constant dance between genes and culture, with technology as the mediator.
It's this incredibly dynamic interplay.
And looking forward, with biotech, AI, digital communication, this rewrite of the human condition is clearly ongoing. It's accelerating, if anything.
Which leaves us with the final thought, maybe for you listening. How will the technologies we're creating right now shape not just our lives, but the future evolution of what it means to be human?
Yeah, it's a profound responsibility, isn't it? The story isn't just written in DNA anymore.
It's also written in the code, the tools, the systems we build. We're active authors in this ongoing story.
Thank you, and we will meet in the next episode. Stay tuned and subscribe and like Quantanix YouTube channel.